All right. So, all right. When it comes to your test there's going to be some vocab matching. So definitely all vocab from section 4.8 on complex numbers, like complex number, real part, imaginary unit, complex conjugates, the sum of perfect squares. You're also going to need to know what the quadratic formula is and what the discriminant of the quadratic formula is. That'll make up at least 90 to 95% of your matching, unless I'm forgetting, in case I'm forgetting something. So as I mentioned, I'm making the test all about the stuff from these last three sections: complex numbers, completing the square, and the quadratic formula. Okay. So first section you're going to get is evaluating complex numbers. Okay, where you'll have to work with powers of I, addition, subtraction, multiplication, division. Okay. So I have an example of one of each up here. So for example, here, I to the fifth. Okay. So if you remember, powers of I follow a particular pattern, right? So I to the first is I squared is -1, right? So 1, let's see, I, -1. I to the third power is -I, and then I to the fourth power is +1, which means I to the fifth is what? I. Yeah. Now, if you wanted to work it out, like if you want to separate them and work them out, and so imagine you're multiplying I 5 times. I'll use a different marker. So 1, 2, 3, 4, 5. Well, both of these are I squared, and these are all -1. -1 times itself is +1, which makes up just I. Okay. All right. So next, when it comes to addition and subtraction is very easy. You just have to remember to combine like terms. For addition, remember these parentheses are here to differentiate one complex number from another. If you see an addition or subtraction, you are not going to FOIL this. Okay. All right. So if you see a plus here or a minus here, you are not going to FOIL it. Okay. So at this point, for addition, you don't need the parentheses. You just combine like terms. Here, here. So 2 plus 4 is 6. 4i minus I is plus 3i. All of your answers should be in the form a plus bi. The only reason that you don't need it here is because, well, this is just 0 plus 1i, and you don't need to write 0 and you don't need to write 1, unless 1 is outside here. Like if it's 1 times anything, you don't have to write the 1. If it's 0 plus something, you don't have to write the 0. Okay. Now, I did say that you're not going to FOIL, but for subtraction, you do have to distribute. Okay. Make sure you're distributing that negative sign to both parts. Okay. 12 plus 5i minus 2 plus I. And again, combine like terms. 12 minus 2 is 10. 5 plus 6 is, no, I already gave it away. 5 plus 1 is 6. 6i. Okay. When it comes to multiplication and division, that's where you're going to be doing some of your FOILing. Okay, especially with multiplication. Okay, first, outside, inside, last. Okay, 8 times 2 is 16. 8 times 7i, that's 56i. I times 2 is 2i. I times 7i is 7i squared. We have to remember that I squared is always what? -1. I squared is always -1. Okay, so that's 16 plus, combine these two like terms, that's 58i. So this is -1. -1 times 7 is -7. And then combine like terms. 16 minus 7, that's 9. My answer is 9 plus 58i. Okay. I squared is always equal to -1. What you got, Johnny? Yes. I squared is always equal to -1. All right. Division. When you multiply, you have to remember to find the conjugate of the denominator. So 2i is my denominator. If 2i is my denominator, what is its conjugate? negative 2i, right? Because remember, this is 0 plus 2i, which means its conjugate is 0 minus 2i. Even if this were like 1 plus 2i, its conjugate would still be 1 minus 2i, okay? So all you're doing is you're changing that sign from plus to minus or minus to plus, depending on what it is. Now, so what you're going to do here is you're going to multiply both the numerator and denominator by the conjugate of the denominator. Okay? If this were more than one term, if this were like 1 minus 2i, you would FOIL, right? So don't forget to do that also. You can also use the sum of squares formula if you have a complex number with a real and an imaginary part. Here, you don't really need to use the sum of squares as much. We'll just go ahead and distribute here. Okay, so here I get, so negative 2 times 3, that's negative 6i. 2 times negative 2, that's minus 4i squared. Negative 2i times negative 2i, that's negative 4i squared. Okay, now, whether it's here or here, you're going to get tempted to try to cancel out the 2i's or the negative 4i squares. Do not do that. Do not do that, because you cannot cancel this out willy-nilly because there's another term in the numerator. Okay, so simplify this as best as you can. So remember, 4i squared is negative 1. So negative 4 times negative 1 is positive 4. So this ends up being 4 minus 6i over 4. Okay, but I'm not done yet, because remember, that's the form that these answers have to be in, a plus b times I. So I have to split up that fraction. 4 over 4 minus 6 over 4 times I. And of course, you want to reduce your fractions. 4 over 4 is 1. 6 over 4 reduces to 3 over 2. There's my solution right there. Okay. Any questions on the complex number portion of the shindig? All right. Now we'll move on to solving quadratic equations. I will allow you to use any method, whether it's factoring, whether it's completing the square, or whether it's the quadratic formula. You can use any method to solve these quadratic equations. With these examples, I'm going to model one using completing the square, and I'm going to model one using the quadratic formula. Okay, this first one, we're going to use completing the square. All right, so again, first step in completing the square is if your a is not 1, then you need to divide by a. So here I'm going to divide everything by 2. This by 2, this by 2, this by 2. Okay, yeah. So that's x squared plus 2x equals negative 4. Now I can go ahead and complete the square. All right, so here's my b. I need to find my b over 2. That's 2 over 2, which is 1. Okay, so when I factor, that's going to come into play later. So now I need to square it. B over 2 squared, that's 1 squared, which is 1. So I'm going to add 1 to both sides. X squared plus 2x plus 1 equals negative 4 plus 1. So now that I've completed the square, I'm going to use this to factor this into a perfect square. So this will factor to x plus 1 squared. And of course, negative 4 plus 1 is negative 3. All right, so now that the left side is factored, I'm going to go ahead and take the square root on both sides. So x plus 1 is equal to the square root of 3. And because I have that negative, I'm going to put an I on the outside of that square root. Please make sure that you don't put your I inside the square root. Write it so that I know that that I is outside the square root. And also, don't forget plus or minus. Don't forget plus or minus. Last thing is to solve for x. Subtract 1 on both sides. X is negative 1 plus or minus the square root of 3 times I. And yes, you can leave your answer like this. If you want to separate them, you can separate them. This would be negative 1 plus square root of 3i, negative 1 minus square root of 3i. So again, if you wanted to separate them, you can, but here you don't have to. Same thing with the quadratic formula. If your fraction for your quadratic formula is completely simplified, you can leave the plus or minus there, or you can separate them. Right? So that's completing the square. Here, quadratic formula. Well, first things first, I want to make sure that this is simplified. All right, so I'm going to multiply across. So that's 12x squared plus 12x equals negative 3. I also want to make sure that everything's on the same side. So I'm going to add 3 to both sides. All right, so that's 12x squared plus 12x plus 3 equals 0. Okay. Also, I want to do one more thing before I start. If you're working a quadratic equation and you notice that all 3 of your terms in your quadratic equation have a common factor, divide it out. Make it easier on yourself. For example, all 3 of these terms are divisible by 3. So I'm going to divide everything out by 3. So that's 4x squared plus 4x plus 1 equals 0. Now I'll go ahead and use the quadratic formula. Okay. First, I want to figure out how many solutions I'm going to have. So I'm going to work out the discriminant first. B squared minus 4ac. So that's 4 squared minus 4 times 1. Okay. So 4 squared is 16. 4 times 4 is 16. 16 times 1 is also 16. 16 minus 16 is 0. So my discriminant is 0. So what does that say about the solutions that I'm going to have? It's going to be one repeated real solution. Okay, and I'll tell you a little bit more about why I'm being more specific. Okay, so I'm going to have one repeated real solution. So let's go ahead and let's try to solve this. Okay, so negative b. So my b is 4. So negative 4 plus or minus the square root of b squared minus 4ac divided by 2 times a, which is 4. Okay, so square root of 0 is just 0, right? Negative 4 plus 0 is the same as negative 4 minus 0, which is negative 4. 2 times 4 is 8. So I get negative 4 over 8, which reduces to negative 1/2. So I only have one solution here. Okay. Now, if your discriminant is not a perfect square, you still have to simplify the square root as much as possible. Okay. If I have the square root of 8, and 8 has a factor that's a perfect square, which is 4, I have to take that 4 out and take the square root of that number and leave the other factor inside. Okay. You have to simplify your square roots. If you have a negative number inside of your square root, then you have to write your answer in the form a plus bi. Okay. If your discriminant is a perfect square, you have to take the square root of that number and you have to evaluate that. Like, for example, let's say that, see how 0 is a perfect square, right? If I just worked it out, that would be negative 4 plus or minus 0 over 8. I still have to work negative 4 plus 0 over 8. Negative 4 minus 0 over 8. And of course, I would still get the same thing, but you have to work that out. Okay? You have to work that out. You have to simplify it as much as you possibly can until you can't simplify it anymore. All right? I will take points off if you don't simplify your solutions or don't write them in the correct form. Okay? But again, you'll be able to use any method to solve quadratic equations. All right, last one. We're going to use completing the square to convert from standard form to vertex form. Okay, so first things first. If your a is not 1, of course, if here we divided by a, here we're going to factor a out. So when I factor out a, I get x squared minus 4x plus 1/2. Okay. Now I'll find my b over 2 squared. Okay, so let's see, my b is -4. It's -4 over 2, which is -2. Now I'm going to square it, which is +4. So I'm going to add 4 here, and I'm going to subtract 4 here, so I can keep it balanced. Okay, so that's 2 times x squared. Actually, I'm going to write this as a bracket here. X squared minus 4x plus 4 minus 4 plus 1/2. So now I can factor this out, and I can combine these two like terms. Okay, so using this number, this factors to x minus 2 squared. All right, -4 plus 1/2. So that's -8 over 4 plus, no, I'm sorry, 8 over 2, I should say. 8 over 2 plus 1 over 2, which is -7 over 2. Okay, so minus 7 over 2. All right, now I'm almost done. The last step is going to be to redistribute this 2 to this part and that part. So that leaves you with 2 times x minus 2 squared, and then 2 times -7 over 2. The 2's actually cancel, and I end up with -7. There's my vertex form. There's my vertex form. The last thing, there is going to be an essay portion for the test. Okay. So for your constructive response question, you're going to have to write a paragraph on either one of these 3 things. Either you're going to write a paragraph on how to solve equations using completing the square, using completing the square to convert from standard form to vertex form, or telling me what the discriminant of the quadratic formula is and how it's used to determine what kind of solutions your quadratic equation will have. It'll be your choice. It'll be your choice to choose one of those 3. Okay.